Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode, we're going to be starting up a new series. It's going to be a little different. This is going to be the first episode of Let's Make a Game, where we make a game of all things. It's going to be kind of a step-by-step process I hope step-by-step process. I don't know. We'll see how this ends up panning out. But I would like to actually make a game from the ground up, starting with a fresh Unity project. This is going to include everything from making the models to scripting everything to texturing stuff. It's hopefully going to cover everything. This series might be a little disjointed or distinct from the actual main series, like the tutorial series is, mostly because I might move at a different rate here than I do there, and depending on what mood I'm in for what video I want to kind of make, this series might end up going a lot faster than the tutorials do. If that's the case and that's confusing, I'm sorry, but I will be doing things in here maybe that I haven't talked about in any of the tutorial series. And if you have any questions about any of that stuff, let me know and I'll answer in the comments, or hit me up on Twitter, however you want to do it. I've been trying to stay as good as I can about getting back to you guys, and if I've missed you, or if I've missed getting back to you, I'm sorry. Send me another message. I've been pretty good about it, I think. Anyway, so the first thing you might notice is that I'm not using Unity 4.3 anymore. I'm using Unity 5, and it has a new project wizard. This is what the project wizard looks like. It's actually a lot better in a lot of ways, I think. I went over to get started. So it loads you on the projects page. I went ahead and went to get started. I entered in a project name and a path and all that stuff. You'll also notice that down here you have a 2D, 3D option and an asset packages option. The asset packages is it's basically the same project wizard as before. It's just differently laid out and different looking. So don't be too intimidated by any of it. I don't think I want any of this for what I'll be doing. So I'm just going to hit done, and I'm going to hit create project. So when I create the project, it's telling me to hold on over my other monitor. And we have Unity. Interestingly enough, not a lot has visibly changed in this. And if you've watched my intro to Unity videos and stuff like that, you'll know that I'm using this, what do they call it, a 2x3 layout that is kind of customized a little bit. I'll be using that for most of the series. This is just the layout that I like the most. So if you want to see how all that stuff works, or if you're already confused and don't know what's going on, I suggest you watch that Unity tutorial series, and I'll post a link right here somewhere on the screen. Hopefully I'll remember to do that. If not, yell at me in the comments. But yeah, so the first thing I want to do is, right now my project structure is blank, so I'm going to go ahead and I'm going to right click on that and hit show and explorer. What that does is it opens up this this window, and it highlights my assets folder. I'm going to open that up, and because I'm prepared, I've made this blank project structure. I used to have one, and in building this new computer and everything, everything got lost. Not everything, just my project structure, my file structure rather. So I kind of made this one, and I think it encompasses most of what I do now. So I'm going to go ahead and copy these over. These are just blank folders. It's just like a, I have it in my game projects in Unity folder. I'm just kind of stored locally on my hard drive somewhere where I can access it and copy and paste it over really quick, because making these folders every time I want to make a game is kind of a pain. And for my own sanity and my own sake, I try to keep all of my project structures coherent, unified, so that they all have a consistent feel across all my projects. Mostly, if I'm ever going to collaborate with anybody, it's nice that I have some sort of semblance of organization. Typically speaking, it's easier to adjust to a semblance of organization than to retroactively organize everything, if that makes sense. So just having a organizational structure is better than not having one at all. I mean, maybe that's self-explanatory, but that's just my mentality. So anyway, my project structure, I think I've gone over this in the past, but just as a refresher: audio, fonts, models, prefabs, scenes, scripts, textures, player data. Player data is where I'm going to store player save data and stuff like that. Anything like settings files, anything like that I want to save out in scripts, that's where it's going to go. Which Spoiler, this game is going to have that stuff, and I don't know that I'm ever going to cover that in a tutorial series, but I am going to do it here, and hopefully you'll be able to see what I'm doing. I'd like it if every video I took a snapshot of this and uploaded it somewhere, and you guys could download each increment of the project. That'd be amazing. I don't know if I'm going to be able to do that for this first one, but I want to start doing that. That'd be awesome. Anyway, sorry, it's kind of a tangent. Textures, pretty self-explanatory. Scripts is a little bit suborganized, so there's like save load, systems, UI, utilities, and all these are empty. General gameplay scripts and stuff are just going to live in this folder with these folders. Maybe that's bad. I don't know yet. We'll see when we get there. Scenes, prefabs, models, fonts, audio. It's all pretty self-explanatory stuff, I think. So come back in here. Just going to import these, and now I have this awesome, like, already built for me structure to start laying files into as I see fit. For example, I'm going to go ahead and hit save to save this scene. Save it in my scenes folder. I'm going to call it Proto. PROTO_01. So the first thing we're going to want to do with any game project, if you've never made a game project before, you're going to want to start figuring out what kind of game you want to make. Like, ideally you already have an idea, but if you're just messing around and, like, say, like, for example, right now, all I know for this is that I want to make a shmup. That's all I know. And I don't know what kind of shmup I want to make. I don't know how I want to necessarily approach it. Like, what kind of special abilities do I have? What, you know, what do I do in the game other than shoot? There's a lot to the design of a shmup that is more than just controls and shooting, right? Like, how do enemy patterns work? How many variants do I want? Do I want levels? Do I want transitions? Do I want bosses? I don't know any of those I don't have answers to any of those questions yet. So what you do is you start broad strokes, right? Like, what's everything that a shmup has? They all have controls. They all have a ship that you control to some degree. They all have, or not a ship, I shouldn't say a ship. They have a object that you control using some method of input, whether that's WASD, arrow keys, joypad, whatever it is, joystick even. They usually have a shoot button. Maybe they have more than one. And that's enough for us to go off of, because that right there implies a lot already, right? Like, you're trying to extrude what you know into things that you can imply the game needs, initially at least. So I know that we're going to shoot, so I know that we're going to have projectiles, so I can start scripting projectiles. Done. I know how those are going to work. Now the other side of this is I don't know if I want to make a 2D or 3D game yet, right? I set the project space up to be 3D. That doesn't mean anything, though. I can totally switch this to being a 2D game whenever I want. So I have to decide how I want that to be. And, you know, this is always the toughest question for me. I honestly don't know. I'm thinking maybe, let's make a 3D one for now. We'll start 3D, and we can always, like, scale it back and morph some stuff into making it 2D again. Yeah, let's go that route. Alright, so we're going to have a 3D shmup, and I'm thinking, you know, a la Star Fox or anything like that. Maybe a little different than Star Fox, maybe more open worldy, I'm thinking. I don't know, we'll see. We'll see. That's tall order. Open world games. Do yourself a favor, don't make an open world game. Like, don't do it unless you know 100% what you're doing and know the time and effort and everything that it takes to go into that. I've seen so many like little indie devs, they're like, I'm going to make an open world game and it's going to be amazing. It's not. It's absolutely not going to be. I have faith that you can make whatever you put your mind to, but that's putting your mind to a lot. And start small. Do yourself a favor and start small. If you've seen some of the games that I've made, I don't know that I've ever posted them anywhere, but if you've seen them, you know that they're... well, I've posted them somewhere. They're on my website, but they're small games. They're not big games. Actually, as a matter of fact, one of them is a shmup. It's a top-down 2D shmup, and it's probably the best game that I've made, that I personally made on my own. But yeah, it's a small game, and the reason why it's one of the best things I've made on my own is because it was small. Anyway, I'm rambling a lot. Let's go ahead and make a new script. We'll start with the projectiles. So we're going to make a projectile. Yeah, like that. There we go. We're going to open this bad boy up, and we're going to start laying in some of our base code for how all projectiles in the game are going to work. This is going to be the dumbest script in the game, I think. It's going to be really, really simple. It's going to have a float value, it's going to have a vector 3, and it's going to have, I think, a raycast check, and maybe a couple other functions and events and stuff. Well, events, quote-unquote, functions. Oh, yeah, this is the thing. I forgot. I found out that you can customize the colors of... Oh, where did I do that at? Tools, options, and in... Oh, where is it? Somewhere in here you can actually edit the look of your... Yeah, was it here? Yeah, it's here. So under syntax highlighting in the options for MonoDevelop, you can actually edit the way that your MonoDevelop looks. And if you've ever looked at code for hours at a time, you know that a dark layout like this, it's so nice. It saves your eyes so much. It's not just that it looks good, it's that it actually like puts less strain on your eyes and actually makes like looking at code something that you can do for long periods of time without like wanting to gouge your eyes out. Anyway, so the projectile class is going to need a couple things. We're going to need a float, and this is going to be our speed, and we're going to default this to 4.0f. The reason why I'm defaulting it to 4 is just, to be honest, it's probably just habit. I just usually all of my speed variables default to 4. It's a good number that it's not too high for linear interpolation. It's not too low for spherical interpolation, or rather, what is it? Ease in, ease out, and linear. I forget what the... Oh... Lerp. It's lerp and slurp is what I know, but I don't know if that's right. Either way, it works for both of them reasonably well. So it's just like a tip. I usually start at 4. You don't have to do it. It's just a personal preference thing. Anyway, next thing we're going to want is a public vector 3, and this is going to be our whoa. Come on. Direction. And this is going to equal vector 3 dot forward. Actually, you know, let's do delta direction. Yeah. And we're going to do vector 3.0. We're already getting bananas with this. This is going to be great. Okay, so the reason why I did this is because I want my projectile to go forward. I don't need to define a direction, right? Like, I don't want to have the projectile facing forward and then going diagonal, right? That's weird. So instead, it's always going to go forward, but we have a delta direction that we can offset it by. So the speed is how fast forward it's going to go. The direction is going to be its turning speed, basically, or the amount that it turns per frame. And then we're going to have another float that is the additional forward offset. That's what it says, right? Additional forward offset. Yep. Whoa. Alright, that's going to equal 1.0. So if we're going forward now, we're actually going to be going forward at 4 right now, because the additional forward offset's going to kick in and it's going to push it farther forward every round. The reason why I'm doing this, by the way, is because I've made a shmup before and I know exactly what I need for the projectiles to work the way that I want them to work. The speed is going to be what the speed at which they move forward. The delta direction is going to be what they use to turn, and the additional forward offset is going to be them moving down lane, or down across the screen rather. So if we want to create a spiral pattern, we set the delta direction to be something like 1 on X, and that means it's going to turn every 1 second. It's going to do a full rotation, to be facing the direction that it started in, and then the additional forward offset is going to move that further forward, but the speed is what's going to determine how fast it makes this loop in delta direction. So I hope that makes some kind of sense, but the speed is what controls the forward, its local forward, and then the additional forward offset is going to be a world forward. Alright, so now what we need to do is say, the other thing we need as a fallback, I almost forgot, is a lifetime, which is going to equal 10 for now, because 10 seconds is a long time. And then we also need a float L timer equals 0f. So the idea behind this is that in the hypothetical situation that you shoot a round down lane and it doesn't hit anything, what happens? I'm going to have a couple fallbacks for when that happens, but those are to come later on down the pipeline. So right now I need a fallback for what happens in that situation, because I don't want to just create a bunch of projectiles and throw them down down the lane and then have them exist forever, and then it's just like this exponential memory leak, right? Like every time you hit the button, well, not exponential, I guess, whatever. You get what I'm saying. Every time you hit the button, it instantiates another thing, and then they never go away because they never hit anything. That's a bad situation to get into. So this is going to be a cap on the amount of time something can exist. It's going to exist after 10 seconds, it's going to blow up. It's going to happen. So you'll see that right here. And sorry if I'm not talking very much. The new situation with my new keyboard and stuff makes my microphone situation kind of weird for the moment. So I'm looking into a solution for that. If that's the case, then actually we're going to have a function here called kill. So what I'm saying is if L timer is greater than lifetime, then we're going to run this kill function that I'm going to create. And sorry about all the typos. Like I said, this is a new rig, and everything on it's a little different. I'm still getting used to the keyboard. Anyway, so on our kill function, we're going to have a bool. Oh, that was my phone going off. I'm sorry about that. Anyway. So in this kill function here, we're going to have a boolean that we're going to call useFX, and that's going to default to false. Actually, it's going to default to true, because I want to use it more than I don't, and when this goes off, I'm going to say false. Alright, so useFX is going to govern whether or not we're going to play a particle effect when this shot hits something, because sometimes we're going to want to do that, sometimes we're not going to want to do that. And in instances where we're not going to want to do that is when, for example, the lifetime expires. It didn't hit anything, the particle effect, or the shot, the projectile, just kind of fizzles out of existence. So we don't want it to play an effect like it hit something, because it didn't. So in that particular instance, we're going to say if useFX hit FX here. So for now, this is just a comment. It's a placeholder section, so we can add the effects spawning and stuff there. But after that, we're going to say destroy well, we'll just do game object. We'll do that. So the kill function is just going to kill this object. So after a certain amount of time being alive, it just disappears. It's kind of what we want. It's kind of what we expect. The next thing we're going to want to do, and actually, I forgot about this. We want to create a layer mask, because we're going to start doing a raycast back from our previous position. I think I did this in a previous video, where I kind of explained it. we're going to do a raycast back from our previous position to our current position to see if we've hit anything. It's a much more efficient way of doing things. And the other thing we're going to want to do is a public enum for, or rather, public enum col type. We're going to say line if I can type today, that would be amazing. And then we're going to say public col type collision wow. What do we want to call this? Naming things is the hardest part of programming, I swear. Collision shape. And hopefully that's not taken. Sweet, it's not. Equals new col type. So the reason why I'm doing this is because we could have shots of different size. So in other words, in the previous game I had a giant ball that was a thing you shot. And that's something that is going to require a sphere cast instead of a line cast, probably, because a line cast is, or a ray cast. I should change that to ray. Oh nope, it's gonna be line because ray's taken. I forgot. If we have a small enough projectile, then we can use a ray cast. But if we have a bigger object, a bigger projectile, then we're going to need a sphere, and then that sphere is also going to need a float value to determine how big it is. So we're going to need, after this, a public float projectile size, and that's going to equal 0.1. This is going to be tiny unless we specify otherwise. Great. So this sets us up to be able to do our as close to perfect raycast and physics checks that we want. And then the layer mask is going to let us cull out certain things, because when I made my last shmup, I ran into an issue where every time you fired a shot, you damaged yourself, and it was really stupid. I was trying to figure out why. And it's because every time I was using a send message on my projectiles, and when I instantiated the projectile, it was clipping into the nose of the player ship, and because it was already colliding with a ship, because it was tagged as a ship, and it extended the ship class, it sent message for damage to the ship, and it sent itself into it, which then handled how it was destroyed and all that stuff. So basically, the gun was shooting itself in the nose of the player ship, and I figured it out really quick what was going on, but it was just like, that was a pitfall. So I'm avoiding that pitfall now. So we're going to make a layer mask that is we're going to call it hit mask, and we're going to call it a new layer mask. So now we have our hit mask, we have our shape, we have our speed, we have direction, we have all these variables we can play with now. So now we actually going to make it a projectile. This is the exciting part. So we're going to say transform.position. Oh, actually, I lied. We can't do that yet. We have to store the vector 3 for our last position. Not vector 2, vector 3 dot position. Sorry. Vector 3 dot 0. I'm jumping the gun. It's also very late at night tonight, and I'm very tired. So I'm sorry if I get a little foggy here and there. We're doing awake. And here's where we're going to set the last position. So last pose is going to equal transformed position. And here we're going to say at the very beginning, last pose equals that. So now we can start to reference this in functions if we need to, the last position, which we're absolutely going to do here. collision. So check collision is going to be a public void check collision. And we could make this return a bool, and we could do all the logic in update if we wanted to. So we could say if check collision, then, you know, handle kill or whatever we want to do. Or we could do it all in check collision. And for organization's sake, I would prefer to do it all in check collision, just because I don't know, I guess it's a personal preference thing. I don't see the reason why I would want to do it in update. I'd like to keep update as clean as possible, just for organization's sake, and having, you know, 4 lines of code in it as opposed to like a bunch, like 4 lines plus another like 10 would be great. So check collision is going to do a cast. Let's see here. We want a ray cast hit, I think, and we're going to say equal ray cast hit equals a new raycast hit. I think that's a thing we can do, right? Right, Unity? We can do that, right? I think we can do that. Yeah, we can do that. It's awesome. Cool. So it's going to equal new raycast hit, and we're then going to say if collision shape please public call type collision shape if collision shape equals, okay, cool, line, I don't know, I must have spelled something wrong in there, equals line, then hit equals physics dot ray line cast, and we're gonna line cast from our previous position, so last pose, to our new position, which is transform dot position, and then we're going to say out hit, and our layer mask is going to be our hit mask. So we're using everything in that, and that's fine and dandy. We're just going to copy the whole thing and paste it, and we're going to say if you are a sphere, then we're going to say hit equals, we're going to delete all that stuff, and we're going to say physics dot sphere cast. Now sphere cast returns a bool, but it also takes a raycast, it also will output a raycast hit. So we're going to do sphere cast, and it's actually, whoa, there we go. It's pretty much the same. Like, you can do vector 3 origin and direction. That is one thing, is it takes a direction. It doesn't take a that's right, I remember this. It doesn't take a destination, I don't think. It takes a ray. It doesn't take, yeah, I remember that now. Okay, so the first thing we're going to want to do is vector 3 origin, which is going to be our last position. Then we're going to want a radius, which is our projectile size. Then we're going to want vector 3 direction. Yeah. See, we want to do a direction to and from, so I'm going to have to create a direction here. There are, I could do this inline, but I really don't want to, just because it gets kind of messy and long and hard to read. So we're going to say vector 3 dot dir, or delta dir is going to equal, oh, come on, vector 3 dot normalize. We're going to say, what is it, the destination, which is our transfer dot position minus the last pose. I believe that'll give us the direction from our last position to our current position. So then we can say delta direction, or what? Delta dir, there we go. Alright. And then Come on, give me the one I want. So we have a direction, and then we have our raycast hit, huh? There we go. That's what I wanted. I wanted the max distance. Okay, so now we do out hit, and then we do float max distance. So the max distance is actually going to be vector3 dot dist. Come on, not down. Distance between our last pose and our current pose. Here, I'm actually going to full screen this so you guys can see this whole line. There you go. Alright, so let me go over this one more time. So we're sphere casting from our last position. We're using a sphere that is the size of our projectile, and we are casting that in the direction of the direction from our last position to our current position, and then we are outputting that data to hit. And the distance that we're going to go is the distance between those two objects, so between those two positions, so our last position and our current position. And then I believe there's one more thing, that is our hit mask. Yep. Hit mask. So assuming that all that is good to go, so we have these if statements and all that jazz, which here I'll make this a little bigger for you guys to see, so you guys can actually read it. So after all this is said and done, we're going to say if hit dot collider is not null, oh come on, then we hit something. So then we're going to say kill. Whoa, this new keyboard is driving me crazy. Alright, we're going to say kill. The other thing we're going to want to do actually is do a send message for damage. We're going to want to do that here. We're going to say send damage message. So the idea here is that we're going to have a new class for damage information. Ideally, we can get away with a lot of stuff for that. And here, I'll just start to kind of make that. So we have a public class damage info. Oh, this keyboard. Oh, it's a great keyboard, by the way. It's just I'm not used to it, and the enter button is in a very weird place. Anyway, so we have that, and we're also going to make it serializable. So we're going to go system.serializable here. And damage info is going to have a couple things. First off, it's going to have a... Oh. Let's make it fancy. Let's do public float max damage. That'll be, I don't know, 2F? Yeah. And then we'll do public float min damage. Ha! Cool. Way to go. Is going to equal 1 float. So now we're going to... This implies that we're going to be able to do a random amount of damage. Maybe we never want that. That's fine. We don't have to do it. But for now, I'm laying it in, and I want to see how it feels. And the next thing we're going to want is a enum for damage type. Maybe we want to be able to have enemies that are more afflicted by electricity damage or something like that. We need the damage. We need the damage to be able to be a certain type for that to be a thing. Maybe we also want a damage mask. Only affects enemies, etc. So what this means is that, like, do we want the enemies to be able to shoot each other? Do we maybe want like an explosion that is a mine that affects everybody? All of these things are things that we have to prepare for in our prototype scripts. So I'm making notes here to say, hey, maybe in the future when you have damage being able to be a thing, you should consider doing this. In the previous game, I had two different layers of damage. Effectively, I had player and I had enemy, and enemies couldn't hurt each other and players couldn't hurt each other. Well, the player couldn't hurt itself, and that helped out a lot with being able to tune the game in a way that was good, good for in every way. So I'd like to be able to carry that on, and this damage mask is how you do that. It's effectively going to be a layer mask, but it's going to be custom. It's going to be like a it might be like if I only want to do the Boolean type mask, I think I did that with an enumerator. I just said, hey, what kind of damage are you? Are you player or are you enemy? And if those two equaled each other when I sent the player info or the damage info, I just ignored it. So like if a player received player damage, I just ignored that and didn't run the script anymore, which is probably a really bad way of doing it. But anyway, so there's that. And then I think I want a public float get damage, and this is going to return mathf dot, oh no, it's random dot range, sorry about that. And we're going to say max damage, min damage. Boom. Done. So there's our damage class. And here's the thing, we have to actually apply that, right? So we have to say, hey, we'll do it here. Public damage info, damage equals new damage info. So now our projectile can, in theory, contain data for damage. It can destruct itself. It has a collision check. It has a fairly intelligent collision check system where we can determine what kind of shape it is, and that's based off of its speed, which we haven't hooked up yet, which is the last thing we're going to do before I call this video quits, is handle movement is going to be the class we're going to make. And it's going to be really, really rudimentary to start, and we're going to layer complexity onto it as we go. But at the moment, we have collision. We choose our collision type. We check for our collision type. We have a hit mask. We have effectively damage if we want that. We're like one step away from it. All we have left is this movement thing, and this projectile will, in theory, work. We'll instantiate it, and it'll just function. So let's do that. Public void handle movement. Alright, so movement is going to be entirely time determined. Well, not entirely time determined. It's all going to be multiplied by time.delta time. That way when we freeze time for pausing, it doesn't break. A lot of amateur Unity games and stuff like that are kind of poorly written, you'll notice that if the game is playing when the pause menu is up and then not playing when the pause menu is not up, that is a state confusion, and they're doing something really, really poor with their pause scripts. You'll also see stuff like, say this was a completed shmup and you fired a shot, you can pause the menu while that shot is still there, and maybe all the enemies will freeze, but the shot continues going. That's also a poorly written script for that. So this is hopefully going to be able to handle that. And the way that we're going to do that is a vector 3 for delta pose. And at the moment it's going to equal vector 3.0. But we're going to modify this with all of our movement values. Actually, yeah, we're going to modify this by all of our movement values, and in the end we're going to say transform.position equals transform.position plus delta pose, but we're going to multiply this by time.delta time. That way, after we're done calculating where it would move, oh, come on. Yeah, there we go. So in here we're gonna mess with delta time or delta pose, and then in the end we're gonna add that to our position, and then we're gonna call it good. Now, one of the things I might want to do that I'm doing in update here is I might not want this. I might say put it here. That way all of the movement stuff, including the last position, which technically governs collision, but whatever, is handled in handle movement instead of arbitrarily in update and in the other. That way we check for life, we move, we check for collision, and that's all update does on a loop every frame, which makes that loop really, really simple, right? And easy to follow. Anyway, so in here we're basically going to say delta pose plus equals So this is where it gets confusing, because we want to base some of this off of forward movement and some of it off of not forward movement. So we're going to say that equals plus equals additional forward offset, which is a float, and we're going to multiply this by vector3 dot forward. So already we're going to be moving forward, and that's something that we should always be doing. But one of the other things I would like to do is say delta pose plus equals transform dot forward times speed. So what that's going to do is it's going to say take the forward vector of our speed, or take the forward vector of our object, multiply it by our speed, and then add that to it. So before that, I'm going to want to change the direction of our object, right? So I'm going to say that transform dot position plus equals delta direction times time dot delta time. There we go. So here we're going to say handle turning, and here we're going to say handle world offset, and then here we're going to say apply changes. So the idea here is that we are restoring our old position right here, and we're setting our new variable, and then we're going to say we want to handle our turning, so turn us the direction that we need to be turning. Wait a second. That's from that position plus equal delta direction. I think I'm doing something wrong here. Delta pose plus equals yeah, this needs to be delta pose. Wait. No, transform dot forward is what I wanted. There we go. Transform dot forward plus equals delta direction times time dot delta time. So the idea is that delta direction is going to be a direction vector that we are going to change by every frame. So if we set it to like 0.25 on the R, then we're going to take a turn to the right, I believe, a quarter turn to the right every frame. So we're going to spin in a circle really fast. And then we're going to say apply, so we're applying that to our forward vector. We're setting our forward vector, and then we're going to take our position, and we're going to our delta position is going to be multiplied into that. Sorry. We're going to take our forward direction, and we're going to multiply that by our speed, and we're going to add that to our delta position. Then we're going to take our delta position, we're going to add our forward offset, and then we're going to change the whole deal. We're going to set our forward position to whatever we want to set it to. It's really hard to explain, but that's what we're going to do. we're doing it. It's happening. I'm saving a bunch, and I'm going to come back in here. It's not telling me there are any errors. It's telling me there are errors. That makes me sad. Alright, so here's our errors. Cannot convert type bool to type raycast. It doesn't like our collision check. This is why you debug in small doses instead of like making a bunch of changes and then seeing if it works. I admit that I have a really bad habit of doing that, and it's not the best. So what we're doing here is we're saying hit equals that. Unfortunately, physics.linecast returns a bool, not a raycast hit. So we need to get rid of that. That's what was happening. And it's doing the same thing down here. That's why we're getting 2 errors. Yeah, that's all it is. So when we come back in here, it's going to re-import the scripts, and everything's going to be hunky-dory, I hope. Boom. Done. Alright, so if we create a new 3D object, create a new cube, and we attach our projectile script to that, you should see all of these things. It's amazing. One of the things I'm going to do next, I hope, is get the which actually the next video that I'm going to create is all about debug in Unity, how to debug your stuff properly. And one of the things I would like to do is I would like, when you have sphere selected here, it will actually show a sphere that is the correct projectile size. But for now, we're just going to do a projectile size of 1. We're going to set the hit mass to nothing, and we're going to set the speed of this to, oh, I don't know, 4 works fine, I guess. I don't know. And it's going to go forward on the Z, so it's going to go forward like that. And there it goes. There's our projectile. It's moving around at the speed of sound. Anyway, so there's our projectile, and after 10 seconds it blew up, if you saw that. So the next test is to increase our projectile speed to like 10. Play it, see how that looks. It's still moving pretty slow. Let's increase that to 30. And what I want to do is I want to set this hit mask to everything, and I want to create another cube. And I want to see if it will hit it and stop and like run that kill function. So this is me testing my script already. So we're going to do this. Alright, so you'll notice that that was a little fast. that was a tad fast. Maybe 30 is a bit much. Maybe we go 20. Just couldn't really see what happened there. So it's going to move forward, and it's going to hit the wall, and it's going to die. Oh, it did it. That's weird. I'm going to pause it. Oh, crap. Alright, I'm going to start it paused, and we're going to walk through this step by step. So we start. Next frame, next frame, next frame, next frame, next frame. And eventually we're going to get there. It's going to hit it, it's going to hit it, and then it, boom, it hits it, and it blows up. So the other thing is that we do this, we look down lane, we grab that guy. Oh. What happened? I'm really confused here. Hang on. What is its lifetime? Its lifetime is 10. What is it hitting? It shouldn't be hitting anything. Oh, is it hitting itself? Oh, that's the dumbest thing ever. Yeah, it was hitting itself. That's stupid. Sorry about that. Anyway, after 10 seconds, it's just going to poof out of existence. So there it is. That was 10 seconds. For the record, the reason why I do this the way that I do it, like with the whole collision shape and stuff like that, is that this is way cheaper than running an actual like box collider or capsule collider on every projectile in your game. So if I can remove this component entirely. I can make this not cast or receive shadows. If I make it an incandescent ball that doesn't have any collision on it, this thing is extremely cheap. And if I don't have any textures on it, for example, I can get this single object down to a single draw call, which is amazing. Like, that is the ideal situation for what you want for a shot, right? Absolutely no render time. Really, really dumb scripts. It's going to behave exactly the way you want it to behave. So actually, speaking of that, let's let's change this to 0.1 and see what happens. We're testing out our direction vector changing. Aha! See how it's slowly curving up now? Because I changed the Y forward to go up slowly. So we change that back and we say maybe 0.2 over here. Then we're going to slowly take a turn to the right, I think? Yeah, we're going to take a turn to the right. So we can contrast this with something like 5. And we'll take the additional forward offset of 2. And we'll end up with something that looks like this. Oh, it didn't do it. Oh, that's the worst. Alright, so there's some work to be done here. I might change the... Instead of doing a directional change, I might do a rotate around. That would be a better way of doing this. Right now what's happening, just so you know, is that it turns to the right, and then it hits its maximum right vector, and then it just stops turning. So it's no longer going to change direction, because it's as far right as it'll go using the setting forward vector. So I have to tell it to do something different. I have to I'm gonna have to rotate it around an axis. That sucks. That's okay though. It's easy enough. Anyway, I think that just about concludes the first episode of this. This is going to be the first one in the series, like I said. I'm going to try to limit this, instead of being an hour long, to being maybe more like, I don't know, 15 minutes, bite-sized chunks. The first episodes are always going to be long on these just because there's setup and there's explanations for what the hell I'm doing. So, sorry about that in advance, but it's just the way that I think this channel should work for now. Anyway. So yeah, thanks for watching, and hopefully I'll see you at the next one. Thanks for watching. Bye-bye.